Okay, the equation of the line. I'm hoping that this is revision from year 10, but like I've said, I'm not going to assume that. I'm going to teach it from scratch. A lot of the purpose of maths is to simplify real-life situations. When you have two related variables and one of them changes a consistent amount while the other variable also changes a consistent amount, I can represent that with an equation. Let's think of this following example. I've got a theme park to get in. It's $10. What's the roll show these days? Is it like 50 or something? There's an entrance fee. Just to get into the gates, you need to pay. You haven't even gone on any rides yet. So here it's $10 to get in, and every ride you take is going to cost $6. So if I go to this park, the total cost to me is going to depend on how many rides I take. So the variables of total cost and the number of rides are going to be related to each other. I could display this info on a table. Do you agree that if I went into the theme park, I would pay $10, and if I took no rides, would it stay at $10? Yeah. You agree with that? If I took one ride, I'd have to pay an extra $6, so it'd be $16 to get in and take one ride. Have I filled that rest of that in correctly? Yep. Have I added 6 each time? So hopefully you see that the variable number of rides, is that going up a consistent amount? What is it going up by?
6.
No, the number of rides. 1. It's going up by 1 each time. What is the consistent amount that the cost is going up by each time? That's the one. I could instead, I missed this one. I am limited by my page space. If I took a ridiculous number of rides, is that the most efficient way of displaying this information? If I took 50 rides, I'd have to have a table that went across, went across, and then maybe went down again, and it would look messy. I can express this in one statement, a linear equation. I can instead express the relationship between total cost and number of rides as a linear equation in this form. I'm hoping this has been hammered into you every year since year 9. Have you seen this before or heard y is equal to mx plus c? Okay? That is the form of a line equation, but it has a specific name. Does anyone know what the specific name of this form of line equation is? It's to do with this. This is the slope. And this is the y-intercept. No one's familiar with the name for... Yes? No. It's to do with slope. This is slope-intercept form. Slope-intercept form of a line equation. What does y stand for? Y is the value of the y variable. It's usually going to be the dependent variable. X is the value of the x variable. It's usually independent variable. Get down to there because I want to explain slope in my own specific way. Because most teachers will say, have you heard this? The slope is rise over run. Have you heard that before? Yes. That's kind of meaningless because why? Do all lines always go up? No. So rise. And also, what does run mean? What direction am I running? Can I run any direction possible? So the way I like to teach slope is a bit more specific, okay? Can you get down to this red star here? So what I usually find is the methods kids will deal with this topic the easiest, but there is only a test on this. And then all the maths after that test is stuff that's in your exam. So this one, just like shares, as soon as you've done DI, you've just done the test, you can forget about shares. As soon as we've done the test on lines, you can forget about that too. All right, I'll get into my explanation of slope. M stands for the slope or gradient of the line. Your previous teachers have probably said slope is rise over run. That works, but there's more to it. I'd rather be specific about it. So whenever you're thinking of the slope, always think of it in terms of a fraction, something over something else. And the top part is the y-step. It's how far the line goes up or it goes down. See how I'm not calling it rise because rise suggests that the line always goes up. Then the fraction bar, and then the bottom is the x-step. So how far the line steps to the right. So let's practice that. If my line looked like this, looking at the grid lines here, if my line went like that and it went up to here, how far has it risen? 2. And how far has it gone to the right? So the slope of this line would be, well done. If I had this line here, did that line go up as I go to the right? How far did it rise? Or did it fall? It went down, -1, and how far across did it go to the right? 1, 2, 3, 4, 5, 6, 7. What would the slope of that line be?
1 over 7.
What sign? -1 over 7. Okay?
Is that because it goes down?
Because it goes down. Yep. -1 over 7. The last one is pretty easy. C is the y-intercept or the starting value of the y variable. Can you get down to that star, please? What is it? Let's see if you sent me an email. Is it okay for me to scroll this far?
Yep.
All right, can you write that example down, please? We're going to express that theme park situation as a linear equation. Let us express the relationship between the cost of going to the theme park and the number of rides given this table of info. What was the constant that the number of rides was going up? How much was it going up each time?
6.
No? 1. Plus 1, etc. How much was the cost going up? That's where you say that. What's the independent variable? Which variable is causing change in the other? Good. The cost isn't telling me how many rides to take, okay? If I take a ride, it's going to cost more. If I take another ride, it's going to cost even more. So it's often useful to mark that, pendant. So this one would be dependent, which makes sense because the cost of something is going to depend on how much I use it. So independent is going to be your x variable, dependent is going to be your y. So now we can work out the slope. Slope is the change in y. Just confirm it there. The y step, up or down. Is it going up? Is the y going up here? Positive. So the slope is going to be 6 over, how far is it going across? 1. So the slope is going to be 6. What's the y-intercept? Well, I just told you. C is the y-intercept or the starting value of the y variable. We start at 10. So y-int equals 10. So equation is, no, I can't say equals because I'm going to do equals again straight away. I'll do a colon. Y is equal to 6x plus 10. You will get a mark for that. I'm telling you right now, in the test it says you need to do it in context of the question. This y represents something. What does the y represent in this situation? The cost or the number of rides? Cost. So to get 4 marks, you would want to write cost equals 6 times by number of rides plus 10. Is that equation now in the context of the question? Because x and y don't mean anything until you bring it back to the question. I'll stop the recording now.